All right. Hey, everyone. Thank you guys for coming early in the morning. My name is Sunny. I'm one of the co-founders of Osmosis, which is a DEX app chain. And today what we'll be talking about is just going through why app chains and what are some of the unique things you can do with your own app chain that you couldn't if you were building on a generalized L1 or a non-application specific chain. So before we hop into why, let's just quickly talk about what is an app chain. Pop quiz. What is the biggest app chain out there today? Anyone? Bitcoin, correct. So anyways, what are app chains, right? So, I like to put it in this political, economic, history timeline where originally in civilization, we had these villages and kingdoms. They're all relatively smaller scale. And you had a little bit of trade happening between them, but not that much. Then humanity progressed to this world of empires where we saw that through mass scale political integration, by putting everything under one common political system, we get massive amounts of interoperability. And this leads to a lot of benefits, right? You get huge economic booms from this, but they come with a lot of cons, right? You got to pay taxes to the empire. You're restricted on a lot of the things you can do when in the realm of the empire. And so that's why today we've moved now towards what I call a world of nation and city states, right? Today we have 190 to 200 sovereign countries in the world. They all are independent politically, but we actually still have a great deal of economic integration between them. And this economic integration is powered by a number of core technologies in the world today. Things like free trade zones, institutions like the UN, which is meant for coordination. You have the World Bank, you have IMF, you have all these institutions that help with this process. You have technologies like the internet, which enable global trade. Blockchain as well, right? Blockchain helps make financial activity between different countries and jurisdictions easier. And you have containerization, which is this not Docker, it's this idea that you can have a standard shipping container that allows you to send products from any port in the world to any other port in the world. This is an analogy for IBC, but that's not what we're talking about today. So in blockchains, we kind of see something similar where early on you had, in the generation one of blockchains, you had these app chains only, right? You have Bitcoin was meant for payments. You had Saya for storage. You have Namecoin for DNS. And then what we eventually, similar to the shift towards empires, we moved towards the Ethereum empire, right? Where we saw that, hey, by putting all of these applications on one system, one political system, one single blockchain, we got all these amazing interoperability benefits, right? ENS, composes very well with the payments of ETH, which compose very well with Uniswap and Aave, and you have all this great composability, but you lose out on a lot as well. You have to pay the taxes to the empire. You have to pay your gas fees in ETH. You have to, you want to change, add some new privacy primitive. You want to capture your own MEV. You can't do that. You have to pay to the empire. And that's why today we see a shift towards a world of app chains. So this is actually a picture from 2017 when I saw the view of app chains starting to come about. So we'll have Augur on its own chain, but we have with app chains today, what IBC enables is that we have the ability to have separate app chains, but still have that interoperability benefits that you get from the empire model. So, and today we finally actually see this live today where, this is specifically the Cosmos ecosystem, but, app chains are bigger than just Cosmos, right? There are many you look at things like Filecoin or Flow or Bitcoin, right? These are all examples of app chains that aren't necessarily Cosmos, but over time, the idea is that as we get more interoperability between these app chains, we're going to see a shift of more and more applications moving off of generalized blockchains into an interconnected ecosystem of app chains. So now let's now that we have a good sense of like what an app chain is, let's talk about why app chains. Well, so this is a tweet from Antonio, and I think he put it very simply that it's like, when you stop caring about alignment and paying homage to if you just focus on your product, this is the natural, app chains are the natural result of the architecture you come upon. And so we'll talk about why that is, right? So number one, scalability, right? You have this idea of one blockchain just can never scale to achieve the goals that it needs, right? You have all these applications competing for throughput on this generalized blockchain, and as soon as there's a popular NFT mint happening or some ICO or something, right? That ends up taking up all the block space of a generalized app and causing this unfair effect to everyone else. So this is a diagram from one of my friends, Dimitri. He had this really good blog post on app chains, and he has this flow chart of what are you trying to build, right? And you'll notice that at the end state that I would hope that if anyone's building a product and you're actually serious about building a $1 billion product, your goal is to scale, right? And no matter what, if you're trying to scale, you end up in either an app-specific L1 or an app-specific L2, right? The only way to get to billion user level scale is you need dedicated infrastructure. You also get a lot of benefits with vertical integration. So Apple builds one of the, I think they build some of the best products in the world, and they do this through insane levels of vertical integration, right? They build a lot of the components, right? They started in-housing if anyone switched to an M1 Mac, you'll realize it's worlds better than the old Intel ones. Because when you control the components and are designing it for your use cases, you can optimize the hell out of it. They build the phone, they build the OS, they own the app store, they build a lot of the apps as well, right? Through this really high level of vertical integration, they're able to build these great products. And this is kind of what what the idea behind app chains as well is, right? It's almost, this is the monolithic thesis, right? Where it's there's some people who believe in modular systems, you want someone else to do the data availability, you want someone else to do consensus, you want someone else to give you, oracles. The problem is when you do this, everyone starts charging a fee, and your costs are going to skyrocket. SpaceX builds the reason they're able to build such cheap rockets is they invested heavily in extreme vertical integration, right? They squeeze out costs at every layer because they realized that every single vendor was scalping them for money, right? And this is what happened when you start to build blockchain applications. You realize that all of these vendors are scalping you on fees, right? And if you want to drive the fees down for your users, you got to start in-housing this functionality. So, something like Osmosis, we own the blockchain, we own the application, we own the primary front end, and with a lot of these smart account and account abstraction work that we're doing as well, we own the wallet as well. Finally, with sovereignty, right? You had situations where Ethereum hard fork upgrades can break entire applications because they change how some gas metering works or something like that, right? You are at the whim of some external party to make sure that your product still continues to work, and that's very scary. So, I'm going to focus more on the vertical integration side, and so we talked about at a high level. I'm going to now talk about some specific examples of what are actual cool things you can do via vertical integration. And I'll use a lot of examples from Osmosis, things that either we've already done or are building, and then I'll use some examples from other products as well. So one example is custom fees. When like I mentioned, when you build on Ethereum, you have to pay gas fees in ETH, right? That is a tax to the ETH asset that you're paying, right? In Appchain, you can pay your transaction fees in your own native token, right? In Osmosis, we could say, hey, we want to pay in Osmo, right? Or in Stargaze, they could say they want to pay in stars. But you can also go a step further, right? You can say, hey, we can pay transaction fees in any token. So this is actually something that we've built on Osmosis. So when you trade on Osmosis, you can pay your transaction fees in any token you want. You can pay in USDC, in Tether, in ETH, in Atom. But what it will do is after you make the transaction, it will collect all the transaction fees that are accumulated by the chain over the course of the day and swap them all into Osmo. So that way all the transaction fees, even though we're providing the UX of being able to pay in any asset, it's still providing buy pressure on our native asset at the end of the day. And then we're actually, we generalize this module and are actually shipping it as a Cosmos SDK module to other blockchains as well. So on something like Stargaze, you'll also be able to pay transaction fees in USDC or ETH, but all those transaction fees will go into Star's buy pressure at the end of the day. You can charge different fees for certain types of transactions. So this is actually something we do in Osmosis today, is that we noticed there was a lot of cyclical ARBs that were like spamming the blockchain. And so what we actually did was, in the blockchain itself, we added a mempool, what we call a filter, and we can detect, hey, is this transaction a cyclical ARB? If so, we're going to charge it a higher gas fee, right? And so this is like something cool that you could only do as an app chain. You can like look at what are the types of transactions that are happening and charge different fees based off of the, different types of transactions have different secondary effects on the product, right? And so we saw ARBs were like, we can allow them to pay more because they're going to continue to ARB, but it brings in more revenue for Osmosis, and it less clogs up the blockchain for our normal users. You have these things called fee credits, right? You can have systems where by doing certain types of actions, we can make it so you get this fee credit, which is not a transferable token, but rather it is a ability to pay, like it is considered a voucher to pay as a substitute for paying your transaction fees in a fungible token. So we can do this for things like, every time you trade on Osmosis, you're paying swap fees. We can allow that to help you accumulate fee credits, right? So that way your actual transaction fee costs are basically subsidized because, our Osmosis's bread and butter is the swap fees anyways. Another one is, for IBC relayers, right? IBC relayers, we can say that, the more packets people relay, they get these fee credits. So that way it reduces the cost for these relayers over time. And then finally, you have these what I find really fun is like non-monetary fee systems, right? So you can imagine something like, you do a little bit of proof of work, you do some hashing or something, then you can make a transaction. The one that we're actually working on at Osmosis is this thing called Privacy Pass. So you've probably never heard of it, but it's basically this in progress W3C standard where, what it does is every time you do a CAPTCHA, it gives you this cryptographic token that you can then use to a site. So the idea is you do a Cloudflare CAPTCHA once, you get 10 tokens. So that way next time you go to a site that wants a CAPTCHA done, you can just pay that token, and that way the site will just bypass the CAPTCHA. So it's instead of having to do a CAPTCHA every time, it's memory stateful CAPTCHAs basically, right? And so we're actually working with Cloudflare to actually how do we bring this on-chain, where we can take these, you do a CAPTCHA, and now you can do certain types of transactions for free on-chain. And this is actually a big part of how we're solving the onboarding problems with every crypto blockchain out there today. You can do a lot of things with custom transaction ordering. So you can do MEV mitigations, right? At the blockchain level, we can say things like no sandwiches, right? We can take a block proposer's block proposal and see, and when we iterate over it, when we execute it, we see, this is clearly a sandwich transaction. Similar how we detected the ARBs, we can say, this is an invalid proposal. You could do things like batch trading. You can take things like, hey, Osmosis is a contrary liquidity system, so we can say, we're going to look at all the transactions in a block. We're going to execute all the liquidity adds at the beginning of the block, then execute all the trades, and then execute all the liquidity removals, right? This is what will give the best execution for the traders on the chain. You can prioritize certain types of transactions, right? So this is something we're working with Pyth on, is we say, hey, all the Pith transaction Oracle updates, this will automatically go to the beginning of the block, right? So that way, a lot of projects have to like build mitigation systems for how do you deal with Oracle lag. We have other solutions for Oracle lag as well, including like in-protocol oracles. But this is, in-protocol oracles will serve some assets. You can also work with Oracle providers that you say like, hey, any Pith Oracle update is automatically going to go to the front of the block. Top of the block auctions, right? Usually the most valuable spot in a transaction spot in a block is the first transaction, because that's where all the arbitrage usually happens. Atom goes up, 5% on a centralized exchange. There's a race to be the first person to do that arbitrage on the DEX. And what we can do is we can sell off the right to do that. So this is basically similar to what like something like Flashbots does off-chain on Ethereum, right? But all that revenue just goes to the validators, right? With Osmosis, with having in-protocol top-of-the-block auctions, all that MEV revenue can go to Osmo stakers as a whole. This is something. So Skip is one of the core dev teams of Osmosis, and so this is one of the products that they built with us. Self-executing code. You can have an in-protocol arbor. So this is something that we also built with Skip, which is called ProtoRev, where it basically says after every trade, the blockchain, it's normally on every other blockchain, you have like external arb bots running that will try to back run trades and do these cyclical arbs. What we actually do on Osmosis is say like, hey, the blockchain can just run these ourselves, right? And capture that as protocol revenue for the chain. So this actually, these in-protocol arbor makes up more transaction revenue than even transaction fees today. You can do things like batch trading, protocol-owned liquidations, right? So, you could say that, hey, at the top of the block, we're going to check the lending protocol, see if anything is liquidatable, and trigger the liquidation automatically from the chain, rather than requiring off-chain liquidation bots that then have to be compensated. Built-in keeper network, similar idea. Other custom execution stuff you can do is like you can add custom cryptography, you can add zero-knowledge verifiers, you can do things like pinned contracts. So this is something that's being activated, I think, in the next upgrade on Osmosis, where we can say like, hey, certain types of contracts are being called constantly, like they're being used in almost every single block. We can pin them and basically keep these contract data in cache or in RAM, right? Rather than having to go to disk, and this will massively help the performance. And you can do this as an app chain because you, as a developer, can, which contracts are like fundamental and important to your chain. You could do things like parallelized computation. This is something that like Say has been doing a lot of work on. You could do things like flash mints. You can, similar to a flash loan, you can say, oh, you can mint infinite of a token as long as you burn it by the end of the transaction. You can do this because you control the entire execution system of the chain, and you can allow systems like infinite mints. This is actually how our in-protocol arbor, the ProtoRev system works right now, is it mints as much tokens as it wants in order to execute arbs, as long as it burns them at the end of the transaction. And then you can do a lot of private smart contracting stuff. Permission contract uploads is something Osmosis does today as well. As an app chain, we don't want our chain being clogged by random NFTs or gaming projects or competing dexes, right? Osmosis governance whitelists which contracts are allowed to be uploaded to the chain. You can build new account models. We're working on this thing called native credit accounts, which is basically this idea that like, I'm kind of running out of time, so I'm gonna go fast. You can add systems that like, you can have native leverage primitives built in to the account model of your blockchain. You have Osmosis smart accounts, allowing a lot of account abstraction and new sorts of like login systems. Today, this goes back to the whole modular thing I was talking about before, right? In Ethereum, you have like this extremely fragmented account abstraction stack, and every layer of this stack is going to start charging its own fees, right? And the account abstraction framework like stack is just going to get very expensive. By having a native in-protocol default account abstraction stack, you can cut out a lot of these fees, right? You don't have to pay the off-chain bundlers and paymasters and the MPC libraries and all of these things. So Osmosis is building this like very native system. I'm gonna click through this. Private accounts. Okay, one of the big ones I think last one I want to bring up is like make your validators do more, right? Like I think this is one of the most powerful things that you get by having an app chain is that you have a set of captured validators that you can demand more of them. So examples, validator provided price oracles, right? There are a lot of perp protocols and lending protocols built on the Osmosis chain. They want access to oracles. Instead of relying on an external provider like Chainlink or Pyth or something like that, we can say, hey, our validators can run oracles themselves and provide that to the chain. The first example of this was actually Terra. So Terra was doing this where they had their validators running Luna price oracles and providing that to the chain. This allows you to have your oracle updates happen much more cheaply and faster. You can have bespoke node requirements, right? So you can say, hey, a project like Secret Network, right? They say, hey, we need all of our validators to have access to an SGX node because that's important for the product that we're trying to build, a very privacy-focused product. You can, you can say, hey, some products might say like, hey, we need our validators to have access to GPUs because we want them to do certain sort of like proving systems that then, the block proposer has to prove certain properties about the block that they want to do, generate a ZK proof, and then it just gets verified by everyone else. You can have something like Arweave, right? It's an app chain that basically requires very high storage capacity of its validator nodes. You get a lot of, you can do a lot of off-chain computation, like order book matching. So this is something that the DYDX chain does. This is one of the main reasons that DYDX switched to Cosmos, is they wanted to have it so their validators could all run an order book in the mempool and have much faster matching and clearing of the order book. You can move a lot of incentive calculations off. You can have you can have your validators act as bridge operators, right? So this is something that Thorchain does, for example, right? They wanted, they're an interchain DEX. They wanted their validators to also be the ones operating their Bitcoin and ETH bridges and whatnot. And then you can do other things like, you can require your validators run data indexers. You can require your validators run routing servers. You can require your validators run front-end hosting, right? Like, if you're trying to build a decentralized application, you have to think about the other layers of your app that need to be decentralized beyond just the blockchain itself, and leaning on your validators to provide a lot of that decentralization infrastructure is a good way about doing that. Finally, I'm way over time, so custom staking, you can have your own staking token, but you can also do really cool stuff like superfluid staking is this idea that you can use DeFi assets in the staking system, right? So in Osmosis, you can use LP shares in the staking system. And now this is being taken to its extreme by projects like Appchain and Initia and stuff like that. So I think that's a really cool thing you can do. And then you can have novel mechanisms as well. I gave a talk at the Urbit conference a couple months ago talking about how they can incorporate NFTs into their staking system. So I think there's a lot of cool novel staking systems you can do as well. So in conclusion, I hope this kind of provides a good brief case study into some of the ways that Osmosis is making use of its app chain functionalities. And people always say oh, would you ever consider migrating Osmosis onto, I don't know, some L2 or something like that? It's we can't, right? Because the product that we're building requires the superpowers of an app chain. So in conclusion, let a world of app chains flourish, and the place to trade all those app chain tokens is on Osmosis.